Everyone, in this video we are going to discuss about atoms and everything that you need to know about atoms. Just the basic aspect of it that you need to know, just the fundamentals that is required when you move forward to advanced studies about atoms and the interactions between atoms. What exactly is atoms? Well, this atom word, it comes from the Greek word known as atomos, and this word was used by the philosopher Democritus 2500 years ago. And what it essentially means is that it's something that cannot be divided or indivisible. And what this essentially means is that, for example, let's assume this here is my gold bar, okay? Let's say this is gold. And now what we do is that we keep breaking this, okay? We keep breaking. And this one we keep breaking. And at one point, we end up with in such a situation that we have a really tiny small part of this hugest thing. And that exactly is known as atom. After this, it cannot be divided anymore further. And that exactly is what it means. It cannot be divided. So it's the smallest part of anything, okay? And atom is all around us. We have around 118 elements of atoms. So this world is actually made of elements. Everything that you see around us, yeah, it's all made up from these 118 elements and the combination of it. It's quite pretty interesting when you actually think deeply about it. And this is the guy, Democritus, that actually came up with this idea, Thomas, and which was all, of course, called bullshit by other philosophers. And it was only a few centuries back that they actually realized, no, that guy actually had a point. And now they have, of course, scientifically proven everything that atoms do exist. Now we would look further into atoms so that we understand what exactly is inside an atom and why is it so important. Well, we can, most of the time, draw an atomic structure using this. First, what does an atom contain? Atom contains proton, neutron, and electron. Now, they all carry a charge and they all contain a mass, okay? So proton, it carries positive. Neutron, as you can see from the word, neutron kind of sounds like neutral, so it doesn't carry any charge, so nothing. Electron, on the other hand, carries negative charge. And if you consider the mass are, as we know, as atomic mass, is only talking about proton plus neutron. Now, hold on. You said there is electron. Why are we not counting electronic mass and atomic mass? Well, the reason is because it's very, very small. It's actually if you consider the relative mass of proton and neutron to be 1 and 1, this one is going to be around 1 divided by 1840. So you can imagine it's really small that even if you don't count it, it doesn't really matter. So when we talk about atomic mass, what we are taking into mind is actually my proton and my neutron. Okay, so that's good. Most of the time when we see an atom, we are talking about a neutral atom. For example, let's say chlorine, okay? And 35. So this is how you normally see in a periodic table when we talk about an element, and the one above, it's actually 35 is actually the atomic mass, while the proton number is given in the bottom, so that is 17. Okay, so this is most of the time neutral, unless there is a charge above it. Okay, so now let's get back into the atomic structure. As we can see, let's just change some color. So as I have said, there are three things that an atom must contain. So first, let's put atom. First, put proton. Proton is always in the nucleus. Okay, so this is where my proton is contained in the nucleus, while we have shells around it, or called orbitals around it, and this is where you will find my electrons. So electrons here, electrons here, electrons here. Now, as I've mentioned, when we say that something is neutral, what does it mean? We mean that the positive charge and the negative charge actually cancels out each other, okay? Now, let's say, okay, let me draw this better. Okay, so this one, as we know, is my nucleus, and it should contain my proton and my neutrons. We normally don't show the neutrons here, but it's also inside there. So now, as we see, we have 3 electrons. So logically, like I've said, if something has to be neutral, it has to cancel out the positive and the negative charges. So this means that these should also have 3 protons. Okay, you get it? So this one actually cancels out each other, and then you can say it's neutral. So what happens? How can something be charged? Okay, so whenever it's not neutral, it becomes an ion. Okay, what does it become? It becomes an ion. So an ion can be cation, or it can be an anion. Cation is when it's positively charged, and an anion is when it's negative. Now, how do I know something's positive and how something's negative? So now we see this is neutral, right? Because we have 3 protons and we have 3 electrons that's canceling out each other. Now, let's say we have 2 protons and 3 electrons. Now we have 2 protons and 3 electrons. Now it's not canceling out anymore. So which one is the dominating charge? It's actually the negative. And what do I say? When it's negatively charged, it's an anion. So this thing is now an anion, because the negative charge is dominating. And there's also another way where you can actually determine. So for example, what we can do is we can actually do a proton minus the electron number. So now we have 2 protons and 3 electrons. So this is going to be -1. And if I had 3 electrons, they would be 3 minus 3, which is 0, which means it's not charged anymore. So what about cation? When does that happen? Well, it's the same thing, when the opposite thing happens. So now, now we have 3 protons, and let's remove one of the electrons. Let me recolor that. So now, what happens here is that we have 3 protons and 2 electrons, and which one is the dominating charge right now? Well, it's definitely the proton. So now it's a cation, so it's no more an anion or neutral charged. Now, what really happens, okay, whenever a chemical reaction takes place, it's always these electrons, okay, these electrons. So what happens to these electrons is that it moves to the other atom, and there's always like a share of electrons or transfer of electrons, which makes some chemical bonding, which of course is another topic, and we are not going to dive into that for here. But this is just really looking into the basic atomic structure to really understand what is happening here. So now we are going to do some basic exercises to really understand how to find the number of protons, the number of neutrons, the number of electrons. Okay. So let's start with chlorine here. As I have said, let's just say this is X, this is A, and this is Z. This one is my atomic mass, and this one is my proton number. So as you can see here, so for this one, so our exercise is going to be to find the number of proton as we see the number of proton there, it's going to be 17. And the number of electron, if it's neutral, it's always going to be the same as the number of protons. So it's going to be Z here. So this one also should be 17. Neutron, on the other hand, it's always A minus Z. What's A? A is my atomic mass, which is 35. And then we have minus Z, which is 17. And as we know, this one is also going to be 17. So that is my neutron number. Now you may wonder what happens when it's charged. So let's say this is charged now, okay? This is charged. So this is no more Cl, but now it's Cl minus. What happens? Does the proton change? No, the proton is not changing. What did I say? Only the electron is changing, right? Whenever we talk about plus or minus, it's mostly the electron that changes, okay? So the proton number stays the same. This proton number, you can also think of this as like a fingerprint, okay? So 17, it's always going to be chlorine, okay? So whenever you see an element that contains 17 protons, it's always going to be chlorine. And so for other elements as well. So the proton number, it's actually makes the element who they really are. So it's always the electrons that's going to be changing most of the time. So, okay, so now we see that there's a minus. Now it's not going to be 17 anymore. When we see minus, that means electron is dominating, right? Which means there's more electrons. So this one becomes 18. Now there's also another way to do it. It's actually Z minus C. And what is C? C is actually, you put the charge there as well. So C is minus 1. So we know Z. It's 17 minus 1, which becomes plus, becomes 18. So that's another way